Okay, so today we're going to start on Unit 7. Okay, we're going to start on 7.1 today. Like I said earlier, you are going to need your books for this unit. Okay, so we're on Unit 7.1. Okay, and what we're working on today is called congruence. Congruence and transformations. Okay, congruence and transformations. So, transformations, first off, what are the 4 different types of transformations that we know of? Translation was the first one we learned about. And a translation is a what? What's a translation is like a slide, okay? What's the next one we learned about? A reflection. Okay, what other ones? Rotation. And then what's the last one? Dilation, right. Okay, so there's 4 different types of transformations that we know of, okay? A translation is a slide. A reflection is when it's like a mirror image. A rotation is when you turn something, and a dilation is when you change its size, so you make it bigger or smaller, okay? Can anyone tell me, what does congruence mean? Congruence means equal, but equal what? Congruence means it's the what? Same what? Same shape. And same size. Okay, so same shape and same size. Okay, and when we say same size, that could mean same like lengths of size, or the sides, excuse me. So side length is the same. Side length is the same. Or the angle measures are the same. Okay, so the side length is the same, or the angle measures are the same. That's what we mean by same size. Okay, so of these 4, are any of these things congruent? Like if you use a translation and you change from one figure to a next, if you just translate something, will it still be congruent?
Yeah.
Yes, it's still congruent. Okay. If you reflect something, is it still congruent?
Yeah.
Yes. If you rotate something, is it still congruent?
Yeah.
Yes. If you dilate something, is it still congruent? No. Okay. Dilation, not congruent. Okay. So more or less what we're going to talk about today is, and this will be in your book, we're going to show you different pictures, okay? You're going to look at different figures and then tell me, are they congruent and why? How could you get from one to the next one, okay? So essentially you're just going to be able to tell me, how would you get from one figure to the next figure? So could you translate it, could you rotate it, or could you reflect it? Okay, so for example number 1, or actually, I'm sorry, for all of them, we're going to say determine if the figures are congruent using transformations. Determine if the figures are congruent using transformations, and then explain your reasoning. Okay, determine if the 2 figures are congruent using transformations, and explain your reasoning. Okay, so explain your reasoning. So for example number 1, now on your homework, everything's going to already be drawn out for you, so it'll be a little bit better. For my pictures, you're just going to like do the best you can, okay? So just, yeah, I'm not an artist, sorry, okay? So this triangle, okay, if this is labeled A, B, and C, okay, and this triangle. Okay, labeled R, S, T. Now, since these aren't on grids, we can't really measure them. Okay, you can't tell me like what are the side lengths. Okay, so you can just kind of look at them. And my drawings are obviously not perfect, but do these look like they are congruent?
Yeah.
Yes, they appear to be congruent, okay? And I'm not going to make you like measure them or anything like that, okay? So, determine if these are congruent. So, yes, these are congruent. And basically, I'm going to know how could you get from this figure to this figure? What would you have to do?
Rotate.
You could rotate, right? Which way would you rotate? You would rotate, you'd have to turn it left, so which way is that?
Counterclockwise.
Counterclockwise. And how many times do you have to rotate it? Just once, so that's 90 degrees. So rotation, counterclockwise, 90 degrees. So if I rotate it counterclockwise 90 degrees, it would be turned right here. Then what would you have to do? Slide it over, okay? So rotation, counterclockwise 90 degrees, then translation. So translation is just when you slide something. Okay? So yes, are these congruent? Yes. And you could prove its congruence by rotation 90 degrees counterclockwise, so that's to the left, one turn, then translation. Questions on how I did that? So we're just telling me how could I get from one figure to another figure.
So you don't have to write any coordinates or something?
You do not have to write coordinates, no. Nope, no coordinates at all. Okay, number 2. Okay, for number 2. If I give you a quadrilateral that looks kind of like that, okay, I'm sorry, R, S, T, and U, and another quadrilateral that looks kind of like that, and this is W, X, oh sorry, I should have drawn that in a different color, W, X, Y, and Z. Sorry, I meant to do that a different color for you guys. Are these congruent, and what's your reasoning behind it?
No.
No, these are not congruent. Why?
They're different shapes. I mean, side to side.
Not congruent. Not the same size, right? Not same size. That's it. Okay, so you're just telling me, are these congruent, yes or no? And this one is obviously not the same size. So technically, the way they wrote this is no sequence of transformations can map RSTU onto WXYZ exactly, okay? I don't need super special math words. I just need to know, are they, like, if they're not the same size, just write not congruent because they're not the same size, okay? If they are congruent, yes, I want you to tell me how you could get from one to the other. Okay, we're gonna do one more example. So I'll let you guys catch up if you need to here. I still see a couple of people writing, so that's why I'll wait for just a second. You all caught up? Okay, last one. For example, number 3. Remember I told you earlier that side lengths being the same makes something congruent, right? So now what we're going to do is we're going to perform a transformation, okay? So for example number 3, okay, example number 3, if I tell you that triangle CDE has vertices, C is at, sorry I lost my place, C is at 1, 4, D at 1, 1, and E is at 5, 1. What I would like you to do is, excuse me, translate the triangle, or excuse, I'm sorry, yeah, translate the triangle by reflecting over the y-axis and translate 2 units left. Sorry, I should have written transform at the beginning, not translate. I used the wrong word. So, I want you to first draw this triangle. Then I want you to transform it by reflecting over the y-axis and then translating it 2 units to the left. So you're going to do 2 parts here. Okay, so first thing I want you to do is we're going to draw it. Okay, you don't have to have grids. They don't have to be absolutely perfect. So you're going to need to go out about 5 spaces in each direction. So first thing I want you to do is start by putting in the vertices. So over 1 up 4. That's point C. Oops, sorry, and I wrote the wrong letter. C. D is over 1 up 1. And E is over 5 up 1. Then, so once you have these, I want you to reflect it over the y-axis. How do you reflect over the y-axis? Is that moving side to side or up and down? Side to side, okay? So reflection over the y-axis, since that means it's not going to move up and down, it's going to stay on the same level. So if D was 1 away, your new D would be here. Now remember, I'm not actually done yet, okay? So I'm just going to draw my marks. Then I'm going to move them to the left, okay? So first, start by, that's your D. C would reflect, its mirror image would be right there. And then E would be how far away?
5.
5 away, okay? So over 5. So I'm going to draw those in there, but don't make them like, super dark or anything yet. Then, from there, I move 2 units to the left for your actual final space. Okay, so if I move 2 units over to the left, this is where your E prime is going to be. Okay, that's where your actual image is going to be. D prime is 2 to the left, so that's your D prime. So the pencil one is kind of like the intermediate, okay, since you don't really want to, like, it's not final, but it's kind of difficult if you don't draw like the middle step, kind of. Okay, and then C is right here, so that's your C prime. Okay. Then from here, I'm going to ask, are the figures congruent? Are the figures congruent? And if so, prove your answer. So, are those 2 figures congruent?
Yes.
Yes. Prove it to me. How can you prove that these are congruent? They're the same size. But how can you tell me what size they are? Like, how can you prove to me what size they are? Can you measure them?
Yeah.
Okay. Could you measure their side lengths? Okay. What is CD's side length? What's the measure of CD? How many spaces is that? 3 units. Okay. We're going to say 3 units. What is its reflected side length? What is C prime D prime?
3 units.
Is also 3 units. Okay. Is it enough to just show that one of them is the same?
Yeah.
No. Nope. How many sides are in a triangle?
3.
3. So how many sides do you have to show that are exactly the same? 3. Okay. How about, what other measurement can you give me? You can tell me DE. How long is DE?
5.
1, 2, 3, 4 units. Goes from 1 to 4. How long is its reflection over here? D prime, E prime.
4 units.
It's 1, 2, 3, 4 units. Now, I know that my little labels aren't perfect, okay? But technically, you could prove this on with grids. Now, we've shown that 2 of the sides are congruent. can I show that these two are congruent?
Yeah.
How?
By stacking.
CE, how can you tell how long this figure is right here, this side? How can you tell that it's 5? So we know that this one's 3, this one's 4. How could you find this side length? The Pythagorean theorem, okay? You could do that, and you should, okay? So Pythagorean theorem says that side length plus side length equals hypotenuse length. So you can make an X there. 3 squared plus 4 squared equals X squared. What's 3 squared? 9. Plus what's 4 squared?
16.
16 is equal to X squared. What's 9 plus 16?
25.
25 is equal to X squared. And then how would you find the square root? You square root it. So what's the square root of 25? 5 equals X. So this side length, CE, would be equal to 5 units. Okay. Can you find this side length? We know that this one is 3, this one is 4. Can you find this side length? How would you do it? The same thing, right? You would use Pythagorean theorem. 3 squared plus 4 squared equals X squared. Right? Now, since we just did this, you don't have to show it twice. Okay? So C prime, E prime is also 5 units. Okay? So it says, are the figures congruent? Prove your answer. Okay? So, yes, they are congruent because of equal side lengths. Okay, so that's one more way that you that you can show congruence. Okay, does anyone have questions on how I did that? Okay, homework today. You guys are going to be working on page 515. You are doing numbers 11 through 14 and 16 through 18. Okay, 11 through 14 and 16 through 18. If you have your book, you can get started now. If you don't have your book, you can look on with the person next to you and you can get started. Okay, so this should be fairly simple. There's only, what, like 6 questions, I think? You can do this.